Alright, today we have relations and functions. So a relation is a set of ordered pairs. The domain, we're going to say, is the set of input or the first values, and then the range is a set of all output or the second values. Okay. Different ways you can write out relations. You can do ordered pairs, which is pretty common right there. You can also take those ordered pairs and put them into a table format. So kind of looks pretty similar. They always say a picture's worth 1,000 words. So you got a graph that you can use. And also this one's not as common, but sometimes you'll see mappings, and then sometimes like you'll have different numbers that repeat. So I guess the -2 happens here twice. So instead of writing it out twice, you just draw two different arrows for both of those. And that's a relation there. So remember, when you're graphing a relation, that it is a set of ordered pairs. You do not need to connect the points on the graph. So a lot of people want to do that. And also keep in mind when you're plotting your points that the horizontal axis is your x-axis and then the vertical axis is your y, and they're always written in the format x comma y. That'll help you graph those. Okay. Big thing that we do a lot in this first unit here is identifying if something is a function or not. So a function, it's a specific type of relation. Function is a relation in which each domain value has exactly one range value. Exactly one range value right there. So that'd be something good to highlight or circle there. To determine if a relation is a function, we can look at the individual points, or we can use something else here called the vertical line test when looking at a graph. And I think we're about to practice both of those. So first two examples determine if any of the following are functions or not. So looking at this first set of data, you want to make sure that each x value here has a different y value. So after looking at all those, you have 3, -1, 2, -2, and 0. None of those repeats, so this is a function. A good way or a shortcut when people are looking at tables and stuff like that, or even order pairs, uh, ask yourself this question: does the x value repeat? Does the x value repeat? Because on this second one right here, if we look here, the x value 3 repeats. And what messes this up here is 3 has two different output values. 3 goes to -1 and 3 goes to -2. So this one is not a function. Alright, and that's, once again, ask yourself, does x repeat? And then if it does it go to different y values right there? So by the definition of a function, uh, that second set right there is not a function. So, and then it also asks us to identify the domain and range. Now when they give you individual data points like this, we're going to just list out the domain like this here. We're just going to write out every single x value. Now it's a really good habit to go in order from smallest to largest here. So I think the smallest right there is at -2. So we'll say -2 for that first x. Looks like -1 is next. And then 0. And then 2 and 3. That would be all your domain values. Okay. And then range. Range is the set of all your y values. So we'll also go from smallest to largest. It looks like the smallest is -1. And then looks like we got 0. And then I guess 1, 2, and 3. Okay. Next one here, I'll do it in a different color since we're kind of crammed. So the next one here, the domain, go from smallest to largest here. It looks like the smallest is -1. And then, or actually, I'm sorry, that's -5. So -5, -1, and then since 3 repeats twice, we really only need to write it once. It's kind of redundant if you write it twice. So just write it once there. That's the best habit right there. Not sure if your teacher will count off or not for it, but just get in a habit. Next here for the range, it looks like the smallest is -1, so we'll go -1, 0, I guess 2 and 4, and then put your little fancy brackets. I know that looks kind of bad there, but that's okay. All right. Next thing that you can do, or actually here, don't forget that if given a relation, the domain and range lists of only the individual x and y values. Okay, so the next thing we can do here is called the vertical line test. I think that was mentioned up here. Vertical line test states that a relation is a function if no vertical line intersects the graph of the relation at more than one point. So like for this first example here, we would see, is there anywhere I can draw a vertical line where this original curve right here, this parabola right here, would it cross twice? And that doesn't happen anywhere, so this is a function. Okay. Now this next one here, it's a sideways parabola. Right, so I could draw like a line here through, 3 or something like that, and it crosses right there at 2 points. So this fails the vertical line test. So we say this is not a function. Okay. Next one here, I guess you got a circle. So draw your vertical line. If it crosses at 2 or more points, this is not a function. Again. Okay. Alright, so let's see what we got going on for this next one. Using set and interval notation, write the domain and range of the function. So this is getting practice doing both of the different ways there. Interval notation, I know that here at Flower Mound we're going to use the interval notation quite a bit. We don't use the set as much, but you still need to be familiar with it here. Now, with this parabola here, it's going up forever, and it's going slowly, but it's going left and right forever. So when we talk about our domain, the domain is always going to be how far to the left and how far to the right, and then the range is how far up and how far down. Now with this parabola here, since it's going left and right technically forever, we say it's all real numbers. Alright, and then the way that we write that here in set notation, you can put your D right there for domain. And then you're going to put the little fancy brackets, you're going to put X, you put this line right here. And then here's some important stuff. You're going to say X, and then they use this Greek symbol right there, and then put an R with a little line through it right there. And that R with a little line through it right there, that stands for all real numbers. I'll go ahead and write that down at the top. So all real numbers. And then you can close your little fancy bracket right there. Alright, now as far as how you write that in interval notation, I like interval notation just because you don't have to put as much fluff with it. So you're going to say it starts, at negative infinity here, and actually I put the wrong thing here. You're going to put a parentheses there, starts at negative infinity, and then it goes all the way to positive infinity. We put parentheses when we're not including, like when you can't bound it. And then since infinity goes, in both directions forever right there, we can't really put a bound on it, so we put parentheses. And I'll show you what it looks like here in a second with the range when you do not use the parentheses. So the range is all of your different y values. So we're going to start out this one here with y. You're going to put that weird little line right there. And then this one's different. You're going to say the y values are starting here at 3, and then it goes up forever. So we're going to use an inequality for that. So we'll say y is greater than or equal to -3. And then close your bracket up. Now as far as interval notation, looks a little bit different here. Since we're actually starting here at the 3 point right there, we're going to use a bracket this time. We're going to say starting at -3. That means including -3, I guess. And then it goes all the way up to infinity. So it might be a good little thing to write here. I guess a bracket means you include. and then a parentheses means, I guess, not included or bounded. So that might be something good to write when you're going back and studying. Okay, so this next section here, using function notation for fx, when you have negative 4x plus 1 right here, what is the output for the given input value? What you got to remember here, if they're talking about an input value for giving us an input value, that means that's an x value. Okay, so what this is essentially saying is plug this in for x right here and then figure out the output value. This fx, by the way, some people that kind of throws them off. Fx is the same thing as y, so this is kind of like y equals negative 4x plus 1. So what we're going to do is figure out the y value that we get when we plug in negative 2 for x. This will kind of go back to your order of operations. So you go parentheses first. You can't simplify inside your parentheses. So then exponents, there's no exponents. So then next is multiplication and division. So we'll multiply those. A negative times a negative should be a positive. So it should be 8 plus 1. And then that should come out to 9. Okay. Now sometimes in the notes and like sometimes in the future lessons here, sometimes they'll write it like this, like f of 2, like this. And that is referring to when x is negative 2. Whoops, forgot my negative here. But make sure you write that down just in case you see that notation. And I'll even write this next one and this one here. So this here is saying your x is 0. Another way you could write it here is f of 0, like that. So we're going to plug in 0 for our x value. And I guess since they didn't give us a new f function, we're going to use that same exact function right here. So we'll say f of 0. I'm going to write it a little bit different here, but I'm going to say negative 4 times 0 plus 1. Okay, and then negative 4 times 0 is 0, and then 0 plus 1 is 1. Okay, so once again, you're just plugging these in for x. Now, this next one here has got a fraction, so we'll have to be a little bit careful when we're doing this. We're going to f of 3/5, which also, remember, that's basically saying this x is this thing right here. So, let's see. So that'll be negative 4, and then parentheses 3/5. And I guess it was plus 1. You can put y over here, you can put fx, I don't really care what you put there. Alright, so reviewing on multiplying fractions here, it's kind of like having a 4 over 1 out in front, and then you can just multiply across both ways. So 4 times 3, I guess that'll be negative 12, and then 1 times 5 will be 5 right there. And you got plus 1. Now, to add or subtract fractions, you need a common denominator, so I'm actually going to change that 1 to 1 over 1 first of all. And then I need to multiply the top and bottom by 5 to get your common denominator. And then, so that'd be 5 over 5. And then you're going to add the numerators. Alright, and then that should be negative 7, I guess, over 5 right there for your final answer. Okay, and if you need to touch up on some fraction stuff, there's probably plenty of videos and stuff like that on YouTube to freshen yourself up on that. But there you go. Big takeaway, they gave you inputs, those are x values, and then don't forget about this. Sometimes you'll see the homework ask you questions like that. So if they put it inside the parentheses right there, you got to go and plug those in. Okay. Next, you're using interval and set notation. What are we doing here? The domain of fx is this stuff here. Alright, the really important stuff, like all of this right here, is just kind of fluff right there. The big things you need to take away from this when they give you a set notation is this stuff right here. So that's saying x is greater than negative 2, but then x is less than or equal to 5. And then apparently our range values just has one bound here. I guess y is less than or equal to 3. So restate the domain and range. of the function using interval notation. Okay, now pay attention to these symbols right here are going to tell you if you're going to have a parenthesis or bracket here. So if it's equal to, if it has that little line right there, that means that it's actually including 5, so we're going to put a bracket there. And then if it doesn't have a little line underneath, x is just regular greater than 2 or negative 2, you're going to put a parentheses. So we'll say from negative 2 with the parentheses, and then comma 5, and then since we're saying less than or equal to, you're going to put the bracket. Now for the inequality here, you don't have like a lower bound, you have y is less than or equal to 3. So you're going to have like a bunch of stuff over here, and then 3, and then since it was equal to, you're going to put a bracket. And since you don't have anything to, I guess, the left of this or under this, something smaller than that, we're going to put negative infinity. So we say it goes from negative infinity to 3. And you can't really bound negative infinity, so that's how you're going to write that one there. So here's your domain, here's your range, and then we're all good on that. Okay, kind of a subtle difference here between the way you do domain and range with a given set of data. Like these right here, classmate wrote the set notation for the values of the domain of the function -6, -5, all the way to -1, as this stuff right here explained the student's error. So I guess the way I would explain this here is we don't have anything like in between -6 and -5. But when you write something in set notation like this right here, we're assuming all values in between -1 and -6. So like all the decimals and all the fractions here. This right here, we don't have like 6.5 right there. So since we don't have 6.5, we can't just say it's between these 2 points here. So I guess your set notation here, right there, that's assuming that the relation is continuous. And what I mean by continuous is that's assuming that there's like no gaps. It's like a continuous line, I guess. So anyways, that is it here for our lesson.